Mars was the outermost rocky planet in the solar system, and was red because the iron. So, yeah, have you ever seen iron that's became rusty? It's a bit of a reddish orangey colour, and Mars is a bit of a reddy, orangey and blacky colour. So yeah, due to lack of oxygen, Mars became rusty. It was kind of like a giant ball of iron, but that's for Mercury. But Mercury's iron isn't actually of rusty. Mars is the second smallest planet. Yeah. Now, as we know, Mars does have water, but where only ice is at its North Pole. We can't see any on the South Pole because we have to go under Mars. So yeah. So yeah. Okay, so yeah. Mars does have water by its ice pack, but it's just evaporating. The water is waiting for its last day since 3.8 billion years ago. Now, here we go to the 3.8 billion years ago theory. By that time, our solar system was beginning to take shape. By that time, it was still relatively young, but all the chaotic was finally over. No more hellish stuff was around. But next to this orangey world is a blue ocean of water, and next to this blue ocean, blue watery planet with green stuff on it, with green continents on it, supercontinents, and Venus. There was a red planet. There was a red planet with water. Now, this might be true that Mars would have been a sustained life 3.8 billion years ago to 3.7 billion years ago. Yeah, so yeah, here's the problems that we need to fix for Mars before colonize. We need to fix its atmosphere. Make sure it's large enough so we can sustain the water. But the tricky part for the atmosphere is how to make it like Earth's. Well, that's going to be a hard method. We don't want like a reddish atmosphere. We want a blue atmosphere with green supercontinents on there. And the most hard part is life to evolve. We have to make sure our second Earth will never becomes habitable to sustain life. But we'll have to kill every single life form on there so we can be extinct, so we cannot evolve. Now the human population is beginning to get too big. So for our colonization, we need to colonize Mars, Titan, Celadus, Europa, or any other moons that have water and can sustain life. So yeah. Now time for ending theory. Now, as we know, 1 billion years from now, the universe will begin to meet its end. I mean the Milky Way. The Milky Way. Hold on. the Milky Way will begin to meet its end. The innermost planets, Mercury and Venus, will be completely killed. Those planets will be no more. But the habitable zone will likely shift to Saturn's orbit. And Titan and Enceladus' ice will completely melt due to the heat. Become water for life. Yeah. Now, there could be a chance that Earth might be swallowed by the sun, but there might be a low chance for Earth to escape and head into a safer orbit. And they're like, oh crap, the sun's expanding, I gotta go. Send on Earth. Mars, you mind if I come into your outer orbit? Yeah. And there you go, Earth is finally saved. But Mars will be super hot by then. We will have to we need to move Earth all the way to Saturn. Saturn will be in the habitable zone. Whoa. Oh crap, I'm falling. Oh yeah, I remember that. It's always day. Yeah. So, 5 billion years from now, Mars will become a planet without any atmosphere. Then we might call it our new Mercury. Let's call it Mercury 2.0. That's a good idea, guys. Oh, guys, to let you know, if you want to build a solar system, the exact same solar system like this, you're going to have this seed. You're going to have this seed if you want to put this on a flat world. And you make sure you get these right on the right height and the right blocks. And also the same size. I'll be doing a measure thingy for the end of the series. I mean, for the end of the season 1. After the end of season 1. Yeah. Yeah, so I think that's mainly it for this episode. I will hope to see you for episode 7 that I'm going